Hi, I'm Simone Maddox and I study bird brains. I'm a grad student here at the U in the Department of Ecology, Evolution, and Behavior, and I work with Dr. Keith Barker. What I'm studying is how birds are affected by our cities. Us here in the Twin Cities live in this big urban environment, and maybe something we don't think about is how the city and urban environments affect the wildlife that lives around us. My research specifically is looking at this front part of the brain called the forebrain, and that's the part that deals with things like novel behavior and innovation. What I'm looking at with the forebrain is in urban populations, if that's going to be larger in density or volume, comparing that to animals that are in these rural spaces. So I'm comparing the size of both their whole brain and their forebrain, that very important innovative center, seeing if that's a different size. I have 4 species that I'm looking at to test this idea. So I have gray catbirds, northern cardinals, black-capped chickadees, and chipping sparrows. 2 of those species are migratory, so we don't see them all the time, and 2 of them are ones that live here all the time. So I put them in this CT scanner, and I take scans, and I can look on the computer at the different size of both their brain and their forebrain. I stain them with iodine, and normally CT scans can only see like bone and things that are of like a higher density, but with the iodine staining you can see all the way through. So I can see the brain itself, and then I can see different parts of the brain. I have a fieldwork component, I have a lab work component, and then I have like a data processing component. And really getting that data back and getting to look at the CT scans that I get to see are so great. Just because it's like the culmination of everything, and I get to see a nice pretty brain, and it's in a nice 3D model that I can turn around and look at, and I really like seeing that part because it really makes me feel like, oh, this is something I can really tangibly feel this. When you have CT scans, you have this digital version of data that you wouldn't be able to keep otherwise. So here in our collections, we have these physical research specimens that are going to be just the outside of the bird. So it doesn't have the full skeleton. It's just what the feathers look like in a given moment. It has like the bill shape, so that's going to be preserved. It has the feathers, and that's going to be preserved. And just the general shape of the bird. Another way we keep different parts of the collection are going to be the skeleton. So this is the full, like all of the bones of the bird, which isn't preserved in this specimen because we have to take all the things out that would rot. What works with CT scans is that they preserve this aspect of this soft tissue that would be lost otherwise in how we normally keep our collections, and we have that information in perpetuity for a given specimen. If you're in an urban space, these urban adapted animals are the ones that you're going to be seeing. So if we can know what's happening to these animals that are going to be our next door neighbors, that's really important because we can know how we're shaping the biodiversity of life. If there are some that are more threatened than others, we can know that we're affecting them. If we are changing important habitats by building cities in that given space, that's going to be important to know. So knowing how we as humans are affecting a given environment by urbanizing it or just moving there generally is going to be really important.